Virtual machines have been the cornerstone of IT infrastructure for the best part of the last 25 years. But imagine a world where virtual machines are no longer needed, no longer running applications, and not even part of the general conversation. On episode 98 of Great Things with Great Tech, I'm speaking to Lukas, Gentele, CEO and co-founder of Loft Labs. And their mission is simple: to provide infrastructure without the need for virtual machines, making Kubernetes multi-tenant, secure, efficient, and cost-effective by building tools that enhance developer productivity, reduce infrastructure waste, and simplify complex cluster management. This is episode 98 of Great Things with Great Tech with Lukas Gentele of Loft Labs. Hey Lukas, welcome to episode 98 of Great Things with Great Tech. It's great to have you here.
Yeah, thanks for having me.
Awesome. Hey Lukas, I've been looking forward to diving back into the world of Kubernetes like we talked about in the pre-show just before we got our stuff together and what we're going to talk about. It's been a while. I feel like Kubernetes has not dropped off the face of the earth, but I think in a good way, it's not become like, it's not this hype cycle part of where it was back in 2 or 3 years ago, right? Which means in theory, it's gained much more mainstream sort of adoption. So we'll get into that a little bit later on. But firstly, I'm interested in yourself. How did you get started in computing and IT? And how did you end up, getting to the point where you were founding Loft Labs?
Yeah, I started programming when I was like, I don't know, 12, 13, something like that, right? And, built my own like little website and then started building our school website back in high school, or I guess middle school kind of time, and started my own one-person little company building websites for the local dentists and lawyers and whatever was in town, right? I think I always had that entrepreneurial kind of spirit. I always had a curiosity for just kind of building things and diving into things, and I think I was maybe a little naive in the sense of like, oh yeah, I can create a business, no problem, right? Um, I think in college I did the same thing. I hired every good engineer I met there, and we started doing contracted work, and
Wow,
that
okay.
was a lot of learning and a lot of fun.
Yeah, I mean, it's funny if you think about a lot of people that started when they were younger or got into computers. I mean, I know that I certainly hacked together a few websites for people when I was out of high school and whatever, and managed to charge a little bit of money for them here and there. I mean, it never really took off, but I kind of enjoyed that side of it because people were after that skill set, and it all came from a bit of dabbling and a bit of tinkering and kind of doing your own thing, and that's kind of how it happens, right? So, is that something that you always had? You always had that desire to code yourself, but I guess what I'm hearing is you did that, but then you realized pretty quickly, if I get other people to do it for me, then I'm going to be more successful in that.
Yeah, I mean, I think in college it wasn't quite as hands-off as it may sound, right? It was pretty much a team effort. But yeah, I definitely realized, okay, how do I go from amplifying myself, right? Like, and the easiest way is to form a team around you, right? And then build things with 5 people, right? Rather than on your own. And I
Yeah.
guess today, building the company, I'm seeing the same thing. We're 60 people now. It's kind of wild, but 12 months ago we're half the amount of folks, and today, if you ask me about especially some specific roles, I'm like, I don't even know how we did this before.
Right.
It's kind of wild.
Yeah. So everything that you've done before kind of is a learning journey to get you to the stage that you're at. I mean, what were you doing so when you're at uni, when you finished uni, because obviously, this isn't sort of the last couple of years. What did you start off with? Where was your first gig in this industry after, the tinkering and college?
Yeah, it was actually quite interesting because through our college, like I was actually working at the chair of artificial intelligence back then, and there was this opportunity to take like a year of it's kind of a research entrepreneurial kind of year, and the government kind of provides you with a salary for a year, and you can
Okay.
it's not a pretty great salary, right? Like folks that went off to work for McKinsey and all of these consultants who are trying to hire us, they obviously had 3x the amount of cash available, but it allowed you to there were no strings attached in that sense, right? It was really like, okay, explore what you want to do, whether you want to become an entrepreneur and start your own startup. And they had these educational pieces where other folks in this program across the whole country kind of came together and exchange ideas, and there were coaches talking to you about how would you start. And it was very interesting
Okay.
for me to dive into that world, because I've built this more of a services kind of business before, rather than an actual startup, not building a product, not raising funding. It's a very different journey if you are in this contractor service-based world rather than the product-focused world. And so there was a lot of learnings for me. I mean, I didn't know what Y Combinator was,
Okay. Yeah.
at the start of that journey even, right?
Yeah. And that
So
comes
there
up
was a
later, I
lot of
believe, as
learnings.
well. Y Combinator comes up later as part of this journey, right?
Yeah, 100%. Yeah, we built this open source project called DevSpace. It's still around. There's still a lot of people are using it. CNCF Sandbox project. Now we handed it over to the CNCF. This project was the starting point. We built it for ourselves, and it was our first tool in the Kubernetes space, because we started working for a lot of companies that were running on top of Kubernetes. We wanted to build software on top of Kubernetes, and
Okay.
the development flow was just rather painful with Kubernetes. So we had to come up with a better way, and DevSpace was our better way, essentially. And
Right.
when
So what is
we,
DevSpace? What is it? Like, this is 2018. This is like, and Kubernetes has only been
yeah,
around what, for like what, 3-4 years, really? And really
yeah,
no,
it's
the
pretty early in the
majority,
Kubernetes journey.
and honestly, the majority don't even know what Kubernetes is. Let's be honest. Like, it's just kind of starting. So what was DevSpace?
Yeah, it's essentially a developer tool for Kubernetes. It is a, if you will, Docker Compose, but for Kubernetes. So, Docker Compose is this
Hmm.
great tool. You run one compose up command, you have a compose file in your repository, right? And you fire up multiple containers, they're interlinked to each other. The developer experience is pretty smooth because you're hooking your local laptop volume into one of the containers, volume mounts, right? So you can essentially rebuild that container really, really quickly by just kind of like having a file watcher rebuilding inside the container. And that way you can iterate super quickly. With Kubernetes, that becomes a little bit more challenging because your Kubernetes cluster may not even run on your local machine. It may run in AWS, and you want to integrate it with services like RDS, for example, and you want to use IAM authentication, like these kinds of things. Like, there's a lot of complexity when it comes to AWS and Kubernetes and other cloud providers, right? So we built DevSpace kind of modeled after Docker Compose, but designed for Kubernetes. We had this file syncing mechanism to hot reload containers effectively, and to do live debugging inside a container. So the goal was really like, it feels like local programming with Docker Compose and a local Docker daemon, but it all happens inside a Kubernetes cluster that may be local or may be remote, right? That
Okay.
was
Yeah.
the goal.
Okay. And then this is like, and this is, so did you have some sort of funding for this? Was this the Y Combinator scenario where you were living there and doing sort of that startup thing? But you weren't like that straight out of college situation though, right? So how did that go? Because you're probably, I mean, you're not that old, but you were a little bit more mature potentially than other people in that sort of space. Did they make you like live like a startup, or what was the deal?
I think yeah, so we applied for Y Combinator at the time. We had this open source project. It's gotten traction, right? There was a lot of attention, and we got hooked on open source as well, right? That was the first time us not contributing a line here or there, like, but us maintaining the project, right? We are suddenly responsible for it. People asked about feature requests, right? We are, pushing the roadmap forward. It was a great experience, and we really fell in love with open source, and we had this idea of, okay, what if we built like a pass similar to like a Heroku based on that DevSpace experience? So we applied for Y Combinator, and Y Combinator was really excited about it. They invited us. They had this final round of interviews. They flew us to California the week after, a Skype interview, and ultimately they told us, hey, it may be a little bit premature, and you have some questions to answer in terms of where this should go. And they were skeptical about passes in general, I felt like, and they ended up being right, because obviously we pivoted and built something different. So they sent us back home and said, like, why don't you apply again in 6 months? We do this twice a year.
Okay.
and you think about these kinds of questions, we'd love to see you again. That was essentially the feedback there. And at the same time, we submitted for a couple of these startup competitions, business plan competitions back in Germany. And, one of these competitions, part of the winning prize we had there was you can apply for UC Berkeley's Skydeck Accelerator program without being affiliated with UC Berkeley, because you'd
Okay.
have to be an alumnus at that school in order to apply. I think they lifted that requirement recently, but at the time that was still a requirement. And neither of us was at UC Berkeley at the time, so obviously that wasn't an option. But through that special grant there, we got in there, and they said like, okay, Y Combinator was excited about you guys, but they told you to come back in 6 months. We'd fund you right now.
Okay.
They're pretty smart about this. We can steal these founders away before they end up at YC, and it's the same experience, right? They bring it kind of. Yeah, no, we try to make DevSpace work, but ultimately building that pass was really difficult. I think building a pass, ultimately you're a hoster. We didn't realize that as much, but
Lots
you're
goes into
literally
that.
competing with AWS, and there's also a lot of other hosting companies that are trying to compete with AWS on a
Yeah.
cheaper price. So the PaaS space is like nobody is appreciating that software layer on top, right? So that was quite challenging. But what it taught us, we had a lot of users in the free tier, not a lot of paying customers, right?
That's the
So
way.
we were
Yep.
forced to build Kubernetes in a very, very cheap and efficient way. And multi-tenancy was the solution for us, because
Okay,
there
here
was
we
no
go.
way we could have handed a Kubernetes cluster to every individual user, but
Yep.
namespaces weren't good enough for a lot of scenarios. So we had to overcome that. And you can kind of see where this is heading. This is our journey towards inventing vCluster ultimately.
Yeah. Because this is the thing, right? This is the whole, I guess this is the whole value prop. This is the whole reason for being. This is the problem statement that you're trying to solve with Loft Labs, is that Kubernetes isn't really very friendly to multi-clustering and shared tenancy. It's just not. Like, I know trying to play with it in the early days and trying to sort of wrap my head around it, different flavors, whatever it was. And I think I mentioned earlier in the pre-show that VMware came the closest, I felt, to some semblance of multi-tenancy, but even that was super clunky with the supervisors and how that did it. But that wasn't scalable because it wasn't cost effective as well, and it still leveraged vSphere and everything like that. So this is the reason why Loft Labs exists, is because you were working through that process, but you had to come up with a way to make everything cheaper. And you thought, why don't we just virtualize this thing and make it multi-tenancy? So how does that come about? So how do you, without giving away the trade secrets, how do you make Kubernetes multi-tenant with vCluster?
Yeah, I think the core idea is really to put a Kubernetes control plane inside a container, but remove the scheduler. And this is all part of the open source vCluster, so there's really no trade secret in that sense in there. You can look at the code and how we did it. We removed the scheduler from the control plane because what a scheduler needs is nodes. And as soon as you need nodes, you have a completely separate cluster, because how do you create a node? Well, that can be a virtual machine or it can be a physical node. All of that would essentially mean you kind of have a separate cluster, right? But when you want to do multi-tenancy, you want to have a set of 400 nodes, and then all of your tenants should somewhat share these nodes. And maybe some tenants get a dedicated node for specific things, right? They need specific privileges in their root containers, host path mapping, these kinds of things. But for your average web server or average type of application in Kubernetes, right, that interacts with message queues, etc., it's totally fine to run on a shared node if you isolate it well and secure it. So the idea was really, let's remove the scheduler. So because one node can only be in one cluster at a time, so one scheduler, right? If we remove the scheduler and instead replace it what we call syncer, we can copy parts from the virtual space. The virtual cluster has its own state, it has its own control plane, separate API server, controller manager, separate etcd, but can also be a SQLite or MySQL or any kind of backing store that we're supporting. It's a whole bunch of options. Then, you create a deployment, replica number 2, that creates 2 pods. Everything so far is just an entry in your data store. Nothing actually happens in terms of spinning up a process, right? Spinning up a
Yep.
container. But now the scheduler is supposed to take that pod and put it on a node. Instead, what we do, the syncer copies the pod to the underlying, real physical traditional Kubernetes cluster. And then that scheduler in this cluster is going to schedule this pod on one of the nodes that is owned by the bigger cluster that's underlying. We call it host cluster. That's the rough magic of vCluster. Obviously, there's a lot more to it in terms of preventing naming conflicts and isolating these workloads and network policies and all of this kind of stuff to make it resilient, right? But this is the essence of it, right? Let's get rid of the scheduler and put this syncer in.
Yeah. So in a way, you're sort of virtualizing, Kubernetes to a certain extent. But then this goes a whole step further with your vNode, which we'll get onto later. But this is effectively what you're doing. You're kind of virtualizing the namespaces and creating enough wrappers around it and enough conditions that the user can log in and have their own multi-tenant component. And that in itself just allows, like you said, it allows cost efficiencies, right? And where is this used? So what were your typical early day customers? What were they looking to achieve with using vCluster?
I think it evolved over time. Initially, when you launch a thing like vCluster, it's a credibility question, because we're going out saying how you guys are doing at this Fortune 500 Kubernetes cluster is the wrong architecture. A lot of people at the time and still today have me doing and spinning up virtual clusters so that you hand out these virtual clusters instead of separate clusters. So initially we saw a lot of traction with pre-production workloads because folks were like, okay, this is a new technology, this is a new architecture. We don't trust this in production quite yet. It's just with containers, right? When containers came out there, it's not like, the biggest banks in the world immediately said like, okay, let's move our mainframe stuff into containers, right?
Yeah.
It took quite some time for people to gain that confidence. And the same happened with vCluster. People used it a lot as sandbox environments, development environments, learning environments, right? Sometimes they ran workshops with vCluster, for example, which I always thought is a really fascinating use case. We never thought of that when we actually launched.
I was thinking that just then, like I think in terms of what we were doing, we were at Veeam. We had Kasten, right, our Kubernetes backup solution, and there were little sort of live labs and workshops that we were running, and that's a perfect use case for that sort of live lab where you're going to spin something up really quickly and just kind of have it ephemeral and shut it down, but have multiple people accessing it without it costing so much money. So you're right, it's out of necessity that these sort of things come in. But then to your point, use cases become clearer in enterprise and commercial senses, and that's where you're at today.
Yeah, absolutely. I think people have understood the vCluster architecture. They have more confidence in Kubernetes multi-tenancy, and they go beyond, CI and dev use cases, and now embarking on, okay, how do we run our production Kubernetes environment in a multi-tenant way? And I think one of the biggest use cases we're seeing recently is going from offboarding of VMware, offboarding of virtual machine-based Kubernetes clusters, and moving towards bare metal clusters.
Yeah,
because you're removing that entire overhead of the virtual machine layer. And the only reason why you had that in the first place is so you could divvy up your environments into multiple nodes and multiple clusters, right? But with bare metal, you can have 500 bare metal nodes in one data center as one big Kubernetes cluster. Then you can have virtual clusters on top instead of creating VMs and then creating these little clusters that are highly underutilized. We see a lot of that happening right now. And the only missing piece besides control plane isolation that you get with vCluster is how do you keep things separate on the node, especially when some of your workloads may need there's noisy neighbor problems, there's requests for host paths, and there's requests for a privileged container, a container that runs as root. And that's highly problematic if you're running in a multi-tenant node. That's why we announced vNode at KubeCon. And that's a very powerful layer that you put on the node to essentially create these virtual nodes and wrap your containers in these virtual nodes to still make them secure without the need to create static virtual machines.
Yeah. So this is last week at KubeCon when this is recorded, at KubeCon, which is, I guess it's the European instance of KubeCon for 2025. Announcement there of vNode, which effectively is trying to eliminate VMs. Get rid of VMs, right? This is your kind of motto you were telling me earlier, which is a very bold statement to make, right? Let's get rid of VMs. Let's get rid of the way that everyone's been doing stuff majority for the last 25 years. But the timing is right at the same time. We all understand the complexity of the world that we're in today with Broadcom and what they've done and how they've forced people into making them look into alternatives, right? So if you're an enterprise or a commercial entity that's been running VMware and all of a sudden you get stuck with what's happening there, you're going to look at alternatives. Typically, the alternatives are, alternate hypervisors for sure with VMs, just moving and doing the migration. And then what we've also seen in the Kubernetes world is KubeVirt specifically, right? But this isn't that. So just make the differential between what vNode is versus what KubeVirt is versus what a VM is.
Yeah, we've heard so many of our customers. Obviously, we work with a ton of companies that have put vCluster to use and that, obviously manage a large estate of Kubernetes clusters. And they've tried several solutions, right? There's things like KubeVirt, as you mentioned, which is essentially just different virtual machines than the ones you get from VMware. And the downside is it's really inferior technology because VMware really built a very efficient, very lean, very quick to start up, right? Like there's so many benefits around that VMware ecosystem that it's really, really hard to move to a technology like KubeVirt, which is much more immature in comparison and may never get to where, VMware ended up being after, 25 years or so, right? Like a lot of innovation and R&D went into the product. But, all of these alternatives that are VMware based or VM based, they have the downside of VMs are still pretty heavyweight. Even the ones from VMware are relatively heavyweight, separate kernels, everything's completely separate. VMs are very relatively static, right? And when you look at containers, we were hoping to turn, these pet VMs into cattle and have dynamic containers on top of that. That was the whole promise of Kubernetes: larger clusters. At Google, there wasn't 500 boards. There was one board that had all of these machines, right? And then the dynamic starting of containers, that is the benefit and allocation of resources dynamically. That's the big benefit that Kubernetes was initially promising. And then we started creating these little 3 to 5 node clusters that are highly underutilized. And now we have pet clusters instead of pet VMs, right?
Yes.
That's essentially what we're trying to fix. With vNode, we are taking the more Kubernetes native approach. Folks have tried to, move to bare metal Kubernetes. We've seen that in our customer base, and they've used vCluster in combination with other technologies. I'll give you a couple of examples, right? Like Kata containers, which creates MicroVMs. Again, still VMs, not ideal. People have used gvisor, which is seccomp filtering. And there's a whole bunch of these other tools, right, that try out alternative ways. What we're using is user namespaces in combination with seccomp filtering. So we don't give you an entirely separate kernel. It's still a container. That virtual node is still made up of a container, but it is as secure as you can get without actually creating a virtual machine. So I think let's say, for example, the drivers are shared, right? If you would be using specific drivers and there's a driver vulnerability, that's potentially one of the only cases where vNode is a little bit less secure than a VM, but it comes at all of the benefits of starting up super quickly, being very dynamic, no static resource allocation, and much, much less overhead. We recently, had a story going out there with a customer of ours called Aussie Broadband in Australia. They're a telco.
Know them well. They're running this podcast right now. They're streaming this podcast.
That's awesome to hear. They went from 200 VMs on VMware to bare metal Kubernetes, 0 VMs. And they are launching virtual clusters on top. And initially they were using gvisor on the nodes, right, which has all kind of limitations. We've seen that with multiple of our other customers. It's very trivial, even with, gvisor, I think, doesn't support even port forwarding and has all these intricacies. It's not using user namespaces, only seccomp filtering. Performance is worse than what you see with vNode. So in these kind of scenarios, using vCluster and vNode is really powerful. And what Aussie Broadband did from 200 VMs to 0 doesn't just save you the VMware licensing cost, it also freed up 1,000 CPU cores and a terabyte of memory just from the overhead of these virtual machines.
Yeah, which I can't
That's what
comprehend.
we're
That's
able to
that's
achieve.
huge. It's huge. It's so significant. And but you mentioned obviously the limitations of the kuberts and the G-Syncs and everything like that. And it's a fair question to ask, I think. Like, what do they give up? Like, if they're moving from VMware, which we know, like I've been a VMware admin for a long time. I loved it, built career out of it, love the tech. It's very feature rich, like you said. So, what do they lose? And are they running? My question there is, what were they running? Are they running sort of Windows boxes, applications on them, heavy enterprise apps, or were they running Linux machines that were a little bit more lightweight, maybe? Like, what was the makeup of that 200 VMs that they could shift it so easily to end up with you guys at vNode?
Yeah, I think one part that is really important to understand is we don't help you with your VMware estate that has legacy applications that are not containerized, right? So most companies out there, they may have, let's say, 500 VMs running legacy applications that are not containerized. We are not going to help you with that.
Okay,
You're
that's
still going to
really
have to
good.
look
That's
into
a
Kubert.
really good. That's absolutely a really good clarification to make for sure. That's great to hear. Yeah.
Yeah, we help you with the applications that are already containerized and where you had to spin up VMs to form separate Kubernetes clusters because
Yeah.
people can't just have one cluster and run everything on one cluster. We just recently spoke to, they're not a customer yet, they are in the POC type stages with us. I can't name any names, but it's a really fascinating story. They had over 5,000 VMs only for their Kubernetes estate. And
Yeah.
they started moving things over to a single big bare metal cluster, and they gave their applications individual namespaces only. The reason why they still have 5,000 of these VMs is these Kubernetes clusters that are running on top of these VMs and the workloads inside require to have the entire cluster, do things across multiple namespaces, have CRDs in Kubernetes, all these things that don't fit in a namespace. So they came to us essentially asking, okay, what if we were to now spin up vCluster inside our bare metal cluster? Could we move these 5,000 VMs over quicker, right? These applications that are running in there, because now it's moving one cluster to another cluster rather than a cluster and trying to mash it into an individual single namespace in Kubernetes. And that's a huge game changer for them. And then there's questions like, how do we isolate things on the node level? How do we give additional privileges to containers that need to run as root, right? And vNode is the answer for that piece as well.
Okay. Get it. Yeah. So yeah, so it's good to make that demarcation, understand the use case there. But certainly, we know that as applications modernize and net new applications get created, they're more than likely going to be cloud native in some way, right? Whether it's PaaS or whether it's from a container perspective as well, it seems just to be the natural way. So this is really banking on the future a little bit in terms of where the modern application is going. Or there'll always be legacy, right? But what you're saying here is, if you've got a cloud native application built in a modern way, there's no point running it on a VM. I think that's when you say get rid of VMs, that's really where you're sticking that flag, right?
So the true cloud native Kubernetes way, container way, right? That's what we're advocating for. Why are we even using that VM? That is the question of the virtualization with virtual machines. I think that's probably pinning it down. And when you're looking at the most cutting edge things going on in the data center right now, it's probably GPUs and all of these, GPU cloud providers rivaling AWS, right? Which
Yep, there's a ton of
AWS
them.
is largely
I've had a couple
CPUs
on the
and
show.
VMs, right?
Yeah, I've had a couple on the show. It's crazy, But we would used to call them high performance compute providers back in the day, but now they're all kind of rebranded GPU providers, And soon there'll be LLM hosting providers, basically. I feel as well, but yeah, this is the point, right? I think this is a world where you need as much efficiency as possible, because what you're trying to do is abstract and slice that GPU, that time, that the transactions per second is what counts here, right? So Yeah,
Yeah,
and
they don't
having
even think
having
about virtual
no,
machines, right?
no,
That
that's
there's the
right.
world of folks that have a lot of virtual machines and build Kubernetes clusters with it, and they want to move away from it. And there's these folks that have never even thought about virtualization because that 30-40% latency and that overhead is way too much for that
Yeah.
expensive piece of hardware that they're selling.
That reminds me of a funny story. I was coming back from an AWS reInvent, probably, I think it was either maybe just before the pandemic or just after, but I was sat next to someone on the plane on the way back. I was talking about what we do at Veeam, just general conversation, trying to make some convo. And he said he never heard of us, and I'm like, well, that's okay. We're the biggest backup vendor in the world. We back up virtual machines. And he goes, oh, what's VMware? He asked me that. He said, I've got no, and it blew my mind that there is this group of people that just don't know about, to your point, or care about virtualization, the VM world. So, let's be honest with you. Like, there's a whole other world out there which, if you're not crossed over like you are, like I am, and others, you wouldn't know about. But certainly, there's a group of people that are just there to do a particular job, develop a certain way, leverage GPUs or leverage something in such a way. They don't care whether it's a VM, whether it's a container, whether it's bare metal. They just want to get the job done. So, what you're enabling here is someone to just get the job done more efficiently, right? That's the way that I'm reading this.
Absolutely. Yeah. Maybe we'll end up building that pass after all on top.
Yeah. Go back to Y Combinator.
Right.
Yeah, you can go back and say, "Hey guys, I told you this was going to be big. Just took us a while to get there." But no, no, no. I think that's really awesome. I think that's it's a great. The reason for why Loft Labs exists is quite clear, and I wouldn't say it happened. It doesn't seem to me like it happened by accident. It happened out of necessity, which most of the companies I have on the show, this is actually how they get to their first product, because they were doing something, it didn't go as planned, or they found a need to augment some bit of technology, and then that presented the actual, reason for being as a company, right? So that's really interesting. And I have to ask, I usually ask at the start, Loft Labs, is something behind the name at all, or how did that come about?
I think it was just a good sounding name. I think we were in a loft, building loft at the time. So,
Loft
but
Labs.
no deeper meaning for the individual letters.
That's
I
deep
may have to
enough.
come up with something at some point.
Yeah, like what does loft stand for? LOF, like something like that. No, literally, you're in a loft building this product, which is awesome. It's like Apple could have been garage if you're talking about the same sort of thing, because
Absolutely, yeah.
Apple was famously built in the garage. All right, so we got a little bit of time left, 5 minutes. Where do you see this going? So, Kubernetes, like I said at the outset, people have stopped talking about it from that hype curve perspective. There's a little bit more of an acceptance that it's just in the background murmuring along. So where do you see this taking Kubernetes? Because I think you're solving a real problem here of that multi-tenancy, which was a huge issue for me, huge issue for a lot of people. So where is Loft Labs going to be going in the next couple of years? Where do you see Kubernetes settling in itself, actually, in a couple of years?
Yeah, it's wild thinking back, and it was just Kubernetes 10-year anniversary, right? Like, maybe 6 months ago or so.
Yeah.
And it's fascinating how when you go to KubeCon, there's still a lot of energy there, but you're right, it is not as much of a hype topic anymore. It is the business as usual kind of thing. And there's innovation still in the space, but I feel like they're more on top of Kubernetes and maybe with vNode below Kubernetes, but around Kubernetes rather than in Kubernetes itself, because Kubernetes is a fairly stable system. And despite the fact that I'm saying this, upgrades are still hard for people, and
Oh yeah.
every day that they're still struggling with the 3 annual upgrades
Oh
of
my
the
goodness.
Kubernetes version. But
Yeah.
we don't have, I think, these. I think Kubernetes has a relatively stable API at this point, and there's a stable set of first layer products. Think of things like service mesh and Istio, for example, or admission control. Like, there's solid frameworks around these problems in Kubernetes, but there are still higher level problems, especially when it comes to GPUs and Kubernetes, more modern workloads like job-based workloads and Kubernetes rather than long running workloads. I think there's still a lot of innovation happening in that space, and for us, we're obviously much closer to the infrastructure layer than the application layer with naturally what we're doing. But we see a lot of this happening, and we see a lot of folks building on top of our technology, which is really exciting. I think there's all of these providers, whether it's like a Spectral Cloud or Refay or Platform 9, these traditional cluster managers, they've all integrated vCluster into their products
That's
and building
awesome.
on top of us, right? For
Yeah.
certain cases.
Big fan of Platform
And
9.
oh,
I was
cool.
there almost at the start of that, helping Suresh do his thing. He's been on the show as well. So yeah, massive fan
Oh,
of Platform
awesome. I
9.
didn't know
Kudos.
that.
Yeah, they're still going on.
Yeah, that's really cool. Yeah, it's awesome to see whenever I spot it in any kind of docs, right? And I see them run examples and tell their audience effectively to, work with vCluster. Or I see folks in the Rancher community demanding opening issues in the Rancher repo. Hey, can you build a vCluster integration as well? Because
That's
like
cool.
SpectreCloud has this too, and we would love to manage virtual clusters just like we manage namespaces and regular clusters with Rancher. It's something we announced at KubeCon as well. I don't think Rancher has listened to their community over the past 2 years and built that integration. So we just went ahead and built it. We open sourced it at
Oh, yeah.
KubeCon last week. And I think we're trying to bring virtual clusters into more spaces, whether it is through collaborations or us just going ahead and building a piece of open source tech that the respective communities can run with because they plug in this extension into their existing platform. But we think more virtual clusters in more places, that's a net positive for the world. So we're trying to make that happen.
Good stuff. So, what's short term? We've got about a minute left. So, give a little bit more about what you're doing in the short term in a minute, and then we'll wrap up.
Yeah, I think in the short term, there's a couple of really exciting topics. One thing is actually having dedicated nodes mounted into the virtual cluster, which sounds ironic because we went away from dedicated
Yeah.
nodes, right?
Yeah.
But for very specific cases, people have asked for that. And what I'm particularly very excited about is once we solve that challenge, because we don't want to actually have a completely separate scheduler in the virtual cluster. So we have to figure out how are we doing this. But what I'm excited about is the end goal of saying, okay, you can also do it in hybrid mode. You can have the regular multi-tenant way and these shared nodes. Plus, I can have this one particular dedicated node. Just think of like your GPU cloud provider, and you're saying, oh, we bought a dedicated one for specific important workloads, but then we have a lot of testing and dev workloads, right? And things where we're experimenting that can run on the cheaper shared infrastructure. That's really fascinating to me. That's what we're working towards in the near term.
Brilliant. Well, hey, Lucas, I mean, this is great. You've solved a problem that I thought about Kubernetes, like when I first was playing with it. That is fantastic. Love what you guys are doing. It's been a really great conversation. I'm sure we're going to hear more about Loft Labs and the technology that you're bringing and kind of changing the industry a little bit as well. So kudos to you. Thanks for being on episode 98 of Great Things with Great Tech.
Thank you, Anthony.
Hey, just as a reminder, thanks for listening to this episode. Stay tuned for more episodes where we continue to highlight companies and technologies shaping our world. Don't forget to follow us on social media at GTwGT Podcast and visit GTwGT.com for more great content and all past episodes. If you enjoyed this episode, make sure to subscribe on your favorite podcast platform and on YouTube. Please spread the word, and if you feel like it, drop a review. Thanks for joining us, and we'll see you next time on Great Things with Great Tech.